Good afternoon, everybody, and welcome to today's virtual Thursday warm-up series from the Euroheat Power Congress. And today we are focusing on episode 5 called Down to the Wire. And today's session is all about industrial residual heat recovery. So thank you all for joining us today, and we're hoping for an exciting and very interactive session. The topic is, while today is the 1st of April, traditional day for joking and messing about, this is not a joking matter, I suppose. We are, at the moment, we are wasting more heat. We're throwing away more heat across Europe than we actually need to heat all of our buildings. So indeed, no joking matter at all. And instead of utilising this heat at the moment, we are throwing it away and utilising and importing fossil fuels. So we have a great lineup of speakers today who are going to talk about the topic in more detail and highlight some of the examples. There's been a lot of research, I suppose, done on this topic, and Euroheat Power have been supporting a lot of projects in this area over the last few years. Particularly, if anyone wants any more, detailed research information on the topics, I would advise you to look at projects like the Heat Roadmap Europe project, which has been going on a long time now, and lots of research there into how we can, a roadmap to 2050, and how we can switch from use of fossil fuels in our buildings to district heating and to utilise these low carbon industrial heat sources. The another project that also Euroheat Power are involved in is Reuse Heat EU. So if you do have a look at that project, there's lots of resources on there on all different types of heat, and interactive maps to show you where those kind of heat sources are available. It's also a very important project and piece of research. So while there are lots of barriers to the uptake of industrial waste heat, so lots of technical and non-technical barriers, there are lots of great examples of how it does work, and how these barriers have been overcome. And I suppose our speakers are here with us today to highlight some of the challenges and highlight some of those very exciting projects that are happening across Europe. So just to start off, we'll just let you know that there is the Q&A box at the bottom of your screen, which if you could please put in your questions as the presentation goes on. We'll take all questions at the end. So after the two presentations, we'll take questions. If you also want to speak, so if you want to ask the question yourself, please raise your hand and we'll get to as many questions as possible. Just to let you know that the session is being recorded and will be available on the platform after today. So I think we'll get stuck right into this session now, and because I know I want to give as much time to questions and answers at the end as is possible. So I'm going to introduce our speakers. So our speakers for today, our first speaker up will be Annita Westenbroek. She is Energy Innovations Manager at the Confederation of European Paper Industries. Her main objective is to accelerate the development and implementation of energy innovations in industry. She is also active as Innovation Manager at the Dutch Association of the Paper Industry since 2011. And the Institute of Sustainable Process Technology since 2015, where she chairs the National Industrial Heat Integration Platform. Again, she's involved in lots of stuff. She's also a director of the Dutch Biorefinery Cluster, which stimulates industrial cooperation in innovative and sustainable circular biomass processing. And I suppose all of her knowledge and background comes from her master's and PhD degree in chemical engineering. So we really look forward to hearing from Annita's experience. And then after Annita, we have another very experienced speaker, Marco Donghi, who is Team Sales Director at CTP, where he coordinates an international sales team supporting the company's plans and strategies worldwide. And he also has a degree in mechanical engineering and technical background working in the boiler and power generation systems area. So what we're going to do is go to Annita first for her presentation, and then we'll go to Marco. And as I said, all questions and answers will be taken at the end. So Annita, I'll pass the floor to you.
Thank you, Donna. And welcome all. Yeah, I will in my presentation go into detail on how yeah, the different ways of valorization of residual heat in the pulp and paper sector. I'm doing this on behalf of CEPI, where I am the Energy Innovations Manager. CEPI is the Association of the European Pulp and Paper Industries. And well, you see a lot of figures on this slide, but in fact, the pulp and paper industry in Europe has, well, many mills across whole Europe, and we are in fact already a quite sustainable sector because we have bio-based raw materials, we have a really high rate of circularity, and we are not only producing the typical paper and board product, you know, but there are a variety of products made from pulp and paper. So if you look around in your home and also outside home, you will see a lot. Well, we have already been active in reducing our carbon emissions for many years, as you see in this graph. So we have been growing as a sector, but we also have been reducing our carbon emissions. And also, if you look at the energy consumption and the energy mix in our sector, you can see that the majority of the energy that is being used is already renewable. But that does not mean that we have nothing to do, because there is still a significant carbon emission by our sector. And also we have a target to halve it by 2030 and even bring it back to zero by 2050. So we know that we have to do that, and we also know that we really need to make our sector, well, less energy intensive, because the availability of sufficient renewable energy that is also competitively priced and also commonly considered irreproachable is and also will stay limited. So we cannot expect that we just move to another renewable energy source, because if everyone does that, then we don't have sufficient for everyone. And also with the available technologies, just doubling the energy savings will be really difficult. So that means that we need technological innovations, and we also need cooperation with other sectors and also with our neighbors. And that's also why I was very willing to give this presentation in this meeting, because cooperation in heat is quite crucial for our sector. So in order to reach our target and to help to accelerate the development and the implementation of any carbon reducing technologies and concepts, CEPI has set up the Energy Solutions Forum. And that is my main role at CEPI, is to coordinate this Energy Solutions Forum. And we have said that we will do it via four means: the exchange of knowledge, provide insight in practical solutions, ensure, of course, that the R&D topics are included in the European R&D calls, but also facilitate the setup of common R&D projects. It does not mean that we will take place in those R&D projects, but we really feel the need to set them up. And well, the second one is, I think, very crucial for also today, because there are so many options. It is difficult for all the companies to know what is possible. So meetings like today and any other, to know what is being done in recovering heat, reusing heat, it is important that we share this with our members. Because if you look at the energy need in the industry, is that 70% of the energy need in pulp and paper making is heat. Heat that we mainly use for our drying processes, for drying the pulp and drying the paper. And this energy that we put in is also lost greatly. Part, of course, we do recover via heat exchangers, but a lot is lost via lower quality heat in our emissions. So this may be either gaseous emissions via the vapor of the drying section, or via the exhaust of the CHP installations that we have. It may also be via warm wastewater a lot of people don't consider this, but yeah, we use water, and water is also discharged, and this water is often at least 20 degrees warmer than the water that we take in. And of course, also our product is warm, which is radiated, maybe the most difficult one to recover. But anyhow, it shows that heat is quite important. And the question is, of course, what do we do with waste heat? And this question is not new. We know already for years that, well, if you of course know, if you walk in a paper mill, you feel the heat. And so we know we have it, and can't we do a bit more with that? So this question is not new, and that is also what you see, is that there are all over Europe, but all over the world, several initiatives where the heat of a paper mill is already disconnected to others. So I just have a few slides. I won't go into detail, but this is a quite recent one where a paper mill in Belgium opened together with Volvo Cars a pipeline between the manufacturing sites, and where the hot water is used to heat buildings at Volvo. So that's, I think, a good example. Then this one is already existing for more than 20 years, where the paper mill Sappi, together with the energy supplier, a company of the city of Maastricht, they have set up a joint venture to deliver the waste heat of the paper mill to the city in Maastricht, both as hot water, but also as cold water, which is produced via absorption cooling based on the heat. And I can, well, another example here is that there is a paper mill in Germany that supplies waste heat to the local swimming pool. And this is also new, because here I have one which is even older, and this picture already shows how old it is, because this was the picture that was next to the article in the newspaper many years ago, when it was announced that the paper mill nearby provided the residual heat to heat the swimming pool. So these are examples of that things are already happening, and these are just a few. And we see also that many companies are also considering discharging heat to the neighboring cities or villages or companies, etc. But you also see that there are many technological developments, and you will see one in the next presentation as well. But we also see that there are advanced heat pump technologies coming up. We have new kind of heat exchangers. We have the ORC. We have heat storage, mechanical vapor recompression, etc. And that also makes us more aware of the enormous value of heat. And also what is quite relevant is that the industries get their own individual CO2 emission reduction targets and ambitions. And that means that if they have to fulfill that and reduce their own CO2 emissions, they will also look more internally. Okay, it's nice to give my heat to the neighboring town or swimming pool, but what can I do inside and internally to do this? So this question about what to do with our waste heat is getting new dimensions nowadays, which means that they look far more like, can I prevent that I get waste heat? So can I use less heat in the production process so that I, of course, also have less waste heat? So thinking about better dewatering before we dry, so we have less water to be evaporated. Maybe direct electric drying. For example, not evaporating it, but removing the water without any heat. And so this kind of innovative drying processes. Also heat storage. So if we have, well, a wet break in the mill, that we store the heat in the meantime and recover it as soon as the machine starts up again. Of course, further internal reuse, heat exchangers are common, but also heat pumps. Can we use heat pumps to make steam again on this of this low temperature heat? And then the last one is in fact external use. So what kind of decision is being made depends on many factors, and the ones that I have included in this slide, and this is my last slide, but I think it's also the most important slide, is that there are a lot of factors that need to be taken into account. So first one is the availability, the size, and the layout of the energy conversion on site. Do they have their own CHP? Do they have an e-boiler? Or do they get maybe steam already from a neighboring high temperature heat industry? So that this is important. Or maybe they buy electricity and have only a steam boiler. This is crucial. Then also, of course, the energy infrastructure. So if we, as a mill, does innovate, then quite often this requires more electricity. Talking about heat pumps or mechanical vapor recompression or e-boilers, it requires more electricity. So also the size of the electricity network will depend on whether they are able to innovate in that direction. And of course, also any, well, regional heat infrastructure is determining. The age of the equipment is relevant, the age of the CHP, but also the age of the equipment in the paper mill. Do they anyhow have to make investments in the near future to replace things? And would this be a chance also to innovate? Then, of course, we have many things on legislation, regulations, and targets. So the CO2 credit thing is an important one. At this moment, the industry is forced to reduce their own CO2 emissions. So which means that if they can't recover the heat themselves and save the CO2 emissions on their own site, that has benefit above sending the waste heat to others. But of course, that also depends on what is infrastructural and financial possible. Also, this ban on waste heat emissions, and maybe it's a strange one for some of you, but I'm living in the Netherlands, and well, apparently there is a kind of heat legislation coming on, is that, well, there will be a sort of, well, chance for others to grab your waste heat if you don't use it yourself. So that means that there is a sort of ban maybe coming up on waste heat emissions. So either you have to reuse it yourself or others have the right to take it. Then, well, as you saw on my former slides, many technologies that are being developed and may already be available that determine whether it is better to use it yourself or share it with your neighbor, or maybe do a sort of shared energy conversion. Regional support schemes, of course, if in the area you live there is specific support for either energy saving measures in your company, or specific support for cooperating with your neighboring organizations, then that is quite relevant, of course. Then the location. Are there any neighboring companies or town? Of course, also quite crucial. And of course, regional initiatives like heat networks being set up. So, but anyhow, I think this shows, and I didn't even talk about any financial incentives here. It shows that regional cooperation and also an integral systems approach, taking into account all these factors, is really needed to design and to achieve the most sustainable solutions. So that's where I would like to end my presentations. Questions will come later. So I would like to give the floor to the next presenter, Marco. To you.
So thank you, Annita, and good afternoon to everybody. My name is Marco Donghi, and today I'm going to present some highlights regarding a very specific sector market, the cement. And I'm going to do this on behalf of CTP, the company that I represent as a sales director. Cement is a crucial sector in view of the 2050 goal for CO2 reduction. As a matter of fact, cement, you have to consider that there are roughly 2,200 cement plants in the world. So these cement plants are crucial producers of CO2 emissions. Today, I'm going to show you the importance of a waste heat recovery system in view of this CO2 reduction and in general to reduce the carbon footprint of this sector. In general, all the cement plants, especially those in Europe and United States, are equipped with technology to reduce emissions. So in all the cases, we are talking about fabric filter or electrostatic precipitator, and in few cases, according to the local regulation, also DeNOx and DESOx systems. These systems are, let me say, good in terms of emission limits, but beside that, there is a side effect. They are also energy consuming. And if we look in the future to the idea to reduce the CO2 as well, there are also other technology like the amine absorption that are extremely energy demanding. In this regard, the cement plants are looking day by day to solutions like the WHR system in order to reduce the cost of electricity. A WHR system in the cement plant is normally based on steam, on organic Rankine cycle. Later on, I will give you some details. In general, the waste heat is used to produce electricity and so reduce the consumption of these systems. Next, please. Okay. In a cement plant, normally there is a big consumption of energy. This energy is used for the clinker production and also for the combustion systems. In general, there are two waste heat sources typically in a cement plant. One is downstream the clinker cooler. The clinker cooler is the equipment used to cool down the clinker after the calcination process. Normally here we have temperature around 250, 300, and even 400 in the most inefficient plants. The other typical source of heat is the preheating tower. So we are downstream the cyclones that are used to preheat the raw meal in the clinker process. Here again, the temperature are variable around 300, 350. We are talking about flue gases from the combustion of coal or natural gases, depending on the cases. These two heat sources are normally used, okay, to recover heat by means of heat recovery boilers. In general, this heat is used to produce electricity, but there are also some side effects. For example, these heat sources can be combined with solar field. This is applicable for the organic Rankine cycle, as we can see later. But also the residual part of heat can be used for district heating. So in this regard, the cement plants can be considered a valuable source of waste heat. The two typical technology used to recover steam and produce electricity, to recover heat and produce electricity are steam Rankine cycle and organic Rankine cycle. In the steam Rankine cycle, we normally use a heat recovery boiler fed by water. Water recover heat from flue gases or hot air, becoming steam, and then steam directly flows through the turbine in a typical Rankine configuration. In the organic Rankine cycle, the situation is different. The heat recovery boilers are fed with thermal oil. This thermal oil is used to transfer the heat from flue gases to an intermediate media. And this media is then used to heat up the organic fluid that flows in a form of vapor in the turbine, producing electricity. There are big differences between the two technologies. First of all, the steam ranking cycle normally needs the use of new employees to run the plant. So skilled and trained people must be present at site to control the chemistry, the physical property of vapor, to do the normal operation and maintenance of the plant. The organic ranking cycle is completely different. It's two closed loops, completely automatic. There is no problem of corrosion or erosion because the thermal oil and the organic fluid are such that the corrosion problem are avoided. And so typically the organic ranking cycle doesn't need any person, any technician to run the plant. It can be even run from remote, from a mobile phone, if possible. Additionally, the steam ranking cycle needs water, and normally has got an impact also in terms of wastewater generated that must be treated by chemicals before the discharge to the sewer. The organic ranking cycle, especially those equipped with an air-cooled condenser, are not using any water. So also in this case, the organic ranking cycle is normally more friendly for our environment. And finally, the organic ranking cycle doesn't need any major overhaul, while steam ranking cycle every 8-10 years typically needs the replacement of blades and part of the rotors. So we can say that from OPEX point of view, the organic ranking cycle is definitely preferable. From CAPEX point of view, normally the steam is a bit cheaper. So steam ranking cycle is normally the right solution in low-cost labor countries. For example, in Asia, in China, they are extremely popular. In Europe, United States, the organic ranking cycle is normally the preferred solution, having lower OPEX. So in 10, 20 years of operation, these OPEX can make the difference. Next, please. As CTP, we have installed, we are, let me say, familiar with the organic ranking cycle. And just to give you a flavor of the possibility of this WHR system in a single cement plant, we prepared this slide. So here you see 3 of our references. The first one in Turkey is a 7 megawatt organic ranking cycle turbine installed on a clinker cooler only. It's a big plant. And in 2 years operation, every year, we have produced roughly 36.2 million of kilowatt hour per year that are equivalent to 15,000 tons of CO2. So it's a big, extremely big reduction. In this case, we produce 11% of the total energy demand of the cement plant. For the other reference that we have always in Turkey, is Somet Cimento. In the last year and a half, we have produced every year 57 million of kilowatt hour per year. So 25,000 tons of equivalent CO2 saved for the environment, and 20% of the internal consumption. We are also installing a new organic ranking cycle in Portugal for our customers. This is very specific because in addition to the clinker cooler and preheating tower, we are also integrating a solar field. So the solar field will generate hot oil, and the same oil will be combined with the heat sources from clinker cooler and preheating tower in order to feed the organic ranking cycle. So this is an even more green solution that the Portuguese government is also partially financing and says is going to apply. In this case, we produce roughly 30% of the internal plant consumption. So just to come to a conclusion, the waste heat is nowadays the correct solution that cement plants are applying for many purposes. The first purpose, for sure, is the reduction of the cost of electricity. That is becoming, especially in a high-cost country for electricity, an issue in terms of competition, in terms of cost for the production of the clinker. In addition to that, the WHR can drastically reduce the carbon footprint of each single plant, and especially where or in view of the carbon tax applied on this business, the WHR is getting more and more important every day. Regarding the WHR, let's say that the payback, the capex are important, because we are talking roughly in Europe an investment between 2,500 and 3,000 euro per kilowatt installed. So the typical investment is million of euro. The payback for these plants is between 3 to 8 years, depending on really case by case the capacity to generation. In principle, the more inefficient is the cement plant, the better is the production of WHR. But anyway, this is a case-by-case story. And finally, this WHR system, especially if we consider the organic ranking cycle, is absolutely environmental friendly. If you consider the organic ranking cycle with the double loop, there is no wastewater, there is no consumption of fresh water as well. And so there are no, let me say, impact on the environment. On the right side, you see a picture of the cement plant of the WHR installed in Turkey with the heat recovery boiler and the air-cooled condenser of the organic ranking cycle. So thank you for your attention. I give the floor to Annita, and hoping to receive any questions.
Thank you very much, Marco. So thank you very much to both Annita and Marco for their great presentations. A lot to fit in the 15 minutes, so I appreciate you guys getting all that information in there. Just to the audience again, just to remind you all that to please do send us in your questions in the questions and answers facility. And we'll get through them as much as possible. If you would like to put up your hand instead, and if you would like to ask any questions out loud, please do raise your hand, and we'll also unmute you and allow you to speak. So yes, we'll start with some. I'll start with some questions. I have some questions myself that we can start with. So. Maybe I think I'll go to Annita first. Annita, I was very impressed to see, I suppose, the interest of the paper industry to be carbon neutral and to be sustainable. And it looks like they've done a lot of work in this area already. So in terms of, the fuel inputs into the sector, it's quite a renewable sector. What is the main driver? Is it costs, or is there a kind of a CSO element that's driving the industry as well? Sorry, Annita, you're just on mute there. Yeah.
Thank you. My computer already warned me. Yeah. No. Yeah. If you look at all the savings that have been done until now, they of course also have a cost issue, and I think it's relevant to know, but that is, I think, holding for every industry. If you do something that only increases your cost, that is not really beneficial for your competitive position. So that means that yes, a lot of things definitely lead to lower costs, but it's not always easy, because we have already done a lot in the cost-effective part, but we have to do more, really more, and not all of these things have a payback time of less than 5 years. So this means that we are also, of course, also active in seeing and how can this be solved? Are there any technological development that can improve the energy of the cost efficiency? But also, are there any supporting means that can help us, or as I told before, maybe cooperate with others in order to decrease the cost? But because nowadays, I think most of the measures that are being taken are really from the ambition of being more sustainable, of knowing that we all have to decrease our CO2 emissions, and also customers ask for more sustainable products. And well, our products are being regarded as sustainable. They're bio-based and circular, but also we see that they can become even more sustainable by reducing our energy consumption and, well, using our heat. Yeah.
That's great. It was very interesting to hear that you spoke about the ban on waste heat that might be introduced, and that waste heat will have to be used in some way. What's the reaction of the industry to this kind of this potential legislation?
Yeah, well, it's a good thing. You know, this is under discussion right now, and we are making the industry more aware that this will come up. And that they are aware, because it's not a kind of ban, it's a collection right. So it's the other way around. So if you live next to a company that discharges heat, then you as a neighbor have the right to collect that heat and ask us what I want to have it. That's in fact, and that they have to cooperate in taking care that you get it. Otherwise, they have to take measures themselves to ensure that this heat is not being discharged anymore. So it is, in fact, not that it's a ban on waste heat, but it's a collection right, which means that if you don't have any neighbor wanting it, then you don't have to do anything. But I think it's a nice way of doing it.
Yeah.
But of course, it's the consequences still need to be realized a bit better.
Yeah, it's like the carrot or the stick approach, you know, whether it's an incentive, you know, this is more of a stick approach, you know, where, you know, you either use it or lose it. So it's an interesting concept. I know that, you know, in the conversations around waste heat and a lot of the conferences, you know, there's a lot of talk on maybe taxing waste heat. And if there was a tax, you know, this would be an incentive, you know, giving it a cost or giving it.
Yeah, but that's a kind of fine indeed. Yes, and this one is more a positive incentive, so we'll go and get it. Yeah.
Yeah, exactly. And Marco, have you seen any reaction from the cement industry, maybe to such incentives, or such kind of stick incentives?
Yes, the cement plants needs this kind of incentive to run this kind of projects. So country by country, the situation is different. For example, in Italy, there are the system of white certificate, or in England, there are some kind of grants covering the 30% of the investment. Another issue could be to boost the system, the carbon tax. Okay, these normally are things that are boosting this sector. Consider that our payback in cement plants goes from 3 years to maximum 8 years, and that the psychological threshold is always 5 years, you know. So especially in those cases where the cement plants are really efficient, so the WHR is not so powerful, the payback risk to be quite long, and so the incentives can make the difference, really.
And for both of you then, you said there about carbon taxes, and I suppose the cost of carbon, like the price on the European trading scheme, has obviously gone up quite considerably in the last couple of years. Has this had any effect on the industry in terms of increasing efficiencies and reducing their emissions?
Yeah, well,
Annita first, yeah.
Yes, well, in fact, you know, if the carbon price increases, then this will change business cases. So which means that a business case that at a low price does not have a reasonable payback time, it will have a reasonable payback time at higher CO2 prices. But what I see in industry is that when calculating business case, they already take into account potential higher CO2 prices in the next years. So they are aware of this when doing investments already. Yeah.
Yeah, so they predicted this would happen. Yeah.
Yes. Yeah, which is logical and
yes,
advisable as well. Yeah,
absolutely. And Marco, do you see an effect on the emissions trading scheme prices?
Well, the carbon tax will definitely change completely the market of cement. The cement market, the process of cement is one of the major producer of CO2. The CO2 comes not only from the combustion. Consider that for the clinker production, for every kilo of clinker, you produce half a kilo of CO2 just for the calcination. So the carbon tax will definitely change the market. The cement plants will be forced to install specific technologies that are currently under the study, under feasibility studies. For example, post-combustion technology like the amine absorption, and these are extremely energy demanding. And so this will completely change the capacity of the market to generate revenue, to generate profit. They need to install this system, so they need to find a good technology, and of course, recover completely the waste heat, because they cannot stay like that. I mean, they need to recover waste heat. So for sure, in the 2050 view, you see a complete change of the market.
And you both mentioned there, I suppose, yeah, market effects and effects of regulation on markets. And I suppose it's quite different, as you said, in different countries, even within the EU. Is this like an issue, I suppose, like trying to replicate industry best practice across different countries? You know, you're working worldwide, and one solution may not just fit into another country quite easily because of the different regulations and different taxes, etc. Is this something that, you know, at a European level, if we had more standardized kind of approaches to this, or a more holistic approach to waste heat, would this help the industry?
But yes, please, Annita.
Yeah, well, I guess we do agree. Yes, it will help. I think it will be much easier also, you know, for getting a level playing field. It is so difficult that one country compared to the other country has different kind of incentives, different kind of energy prices, etc. That it's really a challenge to find out what you can best do. And on the other hand, we really have a big target to reach our CO2 emission reduction in 2030, which means that we would like to cooperate as a whole sector. Yeah. But that is difficult if you have so many different policies and incentives for each of the countries, that what you will develop for one country won't be valid for another one.
Yeah.
So sorry, Marco, now you can.
No, yes, I completely agree. Would help a lot. I would say also in the cement plant. Especially, you need to consider that the cement market is very specific. So the cost of transport to transport 1 kilo of a poor material like clinker can kill. So every single country needs to have its own cement plant. You cannot transfer all the cement plants in the country where you have more incentives. So if we want to save our European, but also worldwide environment, every single country must, let me say, try to support this kind of project, and a kind of common agreement on incentives at European level would help a lot.
Great. So we have a question from a Peter Garfort in the audience, who is asking where there are no current community district energy systems, have you ever considered proactively working with neighbours to develop them, as this is the normal situation in the US or Canada? So maybe we'll go to Annita there first.
Yeah, well, I have to say I'm from the association, so I don't do it, but the companies definitely do. So I think everyone has cooperation and innovation consortia in their region where these kind of things are being considered. So yes, and of course it depends on whether you are a company nearby a town or whether you're a company in an industrial region where there are many more companies with heat. So the kind of things that can be considered are different. But yes, definitely this is being done. Yeah.
And Marco, are there any examples in the cement industry?
Look, around each cement plant, there is always a tremendous pressure, okay, because, you know, it's not so beautiful. So there are some cases where to decrease this pressure, normally the cement plants try to do, for example, district heating, to integrate the waste heat recovery with system that can give benefit to the local population. But I would say that in reality, the cement plant is using megawatt. Okay, it's a very energy-intensive process. So the real thing would be to decrease the internal energy consumption. And the WHR cannot cover external consumption; it can cover part of the internal consumption. So it's better to dedicate this to.
Yeah, that's in fact also what I said is, yeah, of course, it's crucial to reduce it internally.
Yeah.
But it, of course, depends on the external situation, any initiatives, any neighbors, etc. So it's an integral approach. You cannot say it's always this or always that. It's
I think you outlined it very well in your presentation, Annita, the kind of the things, as you said, depends on, it depends on, the energy conversion on site, the infrastructure around the location, how far away. Obviously, distance has a big factor to play. And a lot of these bigger plants, I suppose, wouldn't, as you say, Marco, would be traditionally in the middle of a neighborhood because of their lack of beauty, let's say. But I suppose there are examples where networks have been built over many distances, over kilometers, to connect into nearby dense cities. But I think that's again down to maybe local incentives or local, the national kind of policy framework around district heating. So I think that will definitely be taken into account. I suppose, do the industries look at this as a potential, like, so even after you do reuse as much as possible internally, you were talking there, Marco, about the high temperatures, like, your 250, 300 degrees. Obviously, buildings don't need that kind of temperature. And as we retrofit our buildings, they only require temperatures of 50, 60 degrees. So I suppose there's probably still a waste stream that we can utilize even after you've reused a certain amount. Do the industry see waste heat as a revenue stream? Is there that kind of incentive, like to set the selling of waste heat? Is that an incentive at all?
The problem here for incentives on the selling heat or electricity, normally in many countries these incentives are given to sell the electricity in excess from the internal consumption. And again, it's difficult for a cement plant to produce more than the internal consumption. So normally the WHR system, either in terms of heat or in terms of electricity, is completely used for internal demand. So it's difficult that external incentives can cover part of the expense.
Yeah, but on the other hand, I think I fully agree, because this is of course also how a paper mill works. But in the future, if there are the right incentives, you could think of, for example, a hypothetical case that you have a cement industry next to a paper factory, where together you decide that there is more energy being produced for the cement industry, so that the amount of waste heat at 200 or 300 degrees can still be used for the paper mill to dry their paper, for example, so that the total process is more efficient. But at this moment, there is absolutely no incentive to do so, because we are responsible for our own CO2 emissions. But if we would have a more integral system approach, then these kind of cases could be developed, because then together we will choose for the most efficient system of the combined production of cement and paper. Well, I don't know any case where the cement is next to paper production, but maybe it's there somewhere. But it's just a hypothetical that this kind of cooperation between companies could be initiated when there would be an incentive. But the current incentive is my own CO2 emission reduction.
Yeah. So there's no shared benefits around the CO2 credits.
Yeah, we have had similar thing. I have been working in a kind of issue that, or around biogas, for example, that there was biogas being produced nearby a paper mill, and we can, as a paper company, use this biogas with 100% efficiency, because we have already the boilers to use it. You don't have to treat it. You can only maybe remove some sulfur, but then you can use it. So that was really efficient. But the organization that produced the biogas, they did only get CO2 credits if they would convert it into natural gas and put it on the grid. So that was not the most efficient solution, but the incentive was that they had to do that instead of giving it to the neighbor. Yeah. And these kind of, imperfect incentives do affect the decisions of companies.
Yeah, yeah. So the industrial symbiosis needs to be encouraged.
If I can add, in Italy, there is a very interesting system with these white certificates. So
sorry, I didn't have, can you repeat?
Yes, in Italy, there is an interesting system of incentives based on so-called white certificates. So these are paid by the government for 10 years every year. And practically, these incentives are proportional to the increasing of efficiency. So the more kilowatt hour that you save per year, the more you take for these incentives. These are paid for 10 years, and they can practically double, okay, the saving in terms of electricity cost. So, for example, if you save €1 million of electricity for internal consumption, you have another million from incentives. Okay, this is good because for waste heat, normally these are paid for 5 years, but for a waste heat recovery system in our sector, they are paid for 10 years, and this is really a good boost.
Yeah, that sounds like a good system for us to learn from in some other countries. Just a reminder to the audience as well, don't forget, we do have time for another couple of questions. And so we have another question in here. Do you notice an increased cooperation of your industries with cities and local authorities? For instance, with the greater role they have in energy and heat planning, but would this make any difference? So maybe I'll go to Marco here first.
There are always a cooperation. There is always a cooperation, especially when you talk about district heating. The companies are always looking to potential sources. So sometimes it happens that in our sectors we cooperate with authorities. Consider this is a private sector, so normally they don't speak with with authorities unless authorities comes. This is the point.
Okay, so it's initiated from the authority side. Yeah.
Yeah.
And Annita, your experience?
Yeah, well, I think cooperation with the authorities is anyhow crucial, also for the future energy infrastructure. And because we cannot reach everything with only savings, we also have to change to renewable energy sources. And it's quite crucial that we know that these energy sources will be available. So have a sufficient electricity infrastructure, or maybe in some areas it will be hydrogen, or it will be biogas, or maybe geothermal energy or solar. You know, this is the supply of this energy is mostly not the responsibility of the industry, but it's the responsibility of the industry to indicate what they may need in the future.
Yeah.
And that is the kind of cooperation you anyhow have with your with the authorities to ensure that also in 2030 those two things match.
Yes, yeah. So yeah, it's the future planning together.
Yes.
So that, yeah, they're able to react to industries, and then industry is obviously able to know what kind of energy is available to them in the future. I think that's a big problem we're facing in Ireland at the moment, is as we have a lot of data center industries and a lot of other kind of large energy intensive industries like this, who want to know that large amounts of renewable electricity will be available for them in the future. And obviously trying to plan the electricity system with these large industries is very difficult. So you need to know where they'll be to reinforce the grid in these areas.
Yeah.
So that's definitely going to be an issue in the future.
Yeah.
If there's any more questions, I'll just check if there's any more questions from the audience, and if there's not, I'll see what other questions I have on my list. So actually, Marco, you had an interesting comparison between the steam Rankine cycle and the organic Rankine cycles, and that you offer to as a service to the cement industry. And you mentioned the differences in OPEX and CAPEX. I wonder, is there much difference in the actual efficiency of both of the systems? And is there a difference in maybe the health and safety issues with either of the different types?
Yeah, there are many things in this decision. In general, steam Rankine cycle from CAPEX point of view are less expensive than the organic Rankine cycle, but on the opposite, the organic Rankine cycle are much better in terms of OPEX. So this is a first, let me say, pure financial analysis. If you consider to stay, for example, in Europe, and you consider a minimum of 10-year lifetime, the OPEX are normally winning choice. So the organic ranking cycle normally is the winning one. If you are, for example, in Asia, the steam ranking cycle is the most popular one. But there are also other aspects. I mean, first of all, let me say, is the impact on the water. Now, water is, of course, CO2 is important, but water is another important issue. And many times, many cement plants are not authorized to use additional water respect the quantity already used. And so the organic ranking cycle can help the final user to respect the limits given by the authority as well. In terms of health and safety, of course, there are many directives like ATEX or Seveso directives imposing some restriction and some regulation regarding the organic ranking cycle. So when you wanna consider the installation of organic ranking cycle, also there is this kind of issue. Even I have to say, in the installation that we have with the organic ranking cycle, let me say, the plant is extremely safe as well as steam. Okay, so it's not a technology that is demanding from the health and safety point of view. In general, the business plan must consider both the CapEx and the OpEx, and the OpEx can be a very important surprise, okay, in this decision.
Yeah, it was interesting actually to hear the difference in the.
An additional thing I would say that in the organic ranking cycle, especially with low temperature sources, are better in performances. Okay. So the higher is the temperature, steam of course is the winner, but the lower are the temperature, the organic ranking cycle became more performant.
Okay, great. Yes, actually, it was interesting to hear the difference. Obviously, from an industry point of view, having less employment was a good thing because you're obviously lowering your overheads, and if you have particularly high labor costs in those areas. But I suppose from a political point of view, one of the things that drives renewable policy and efficiency is around job creation. So when you're selling it to, when we're selling it to local politicians here, we're always talking about how many jobs it will create rather than how many jobs it'll offset. So obviously a different perspective then from the industry.
Absolutely.
Yeah. And Marco, another question for yourself then, just to wrap up then. Is there a big market potential in the EU for these kind of efficiencies in the cement industry?
There is a huge potential. We are talking about 3 gigawatt of thermal power still available. Okay, so it's a huge potential. There are many plants in every single country. Let's say, of course, the majority, only few of them are already equipped with WHR. So the potential in our sector is tremendous.
Great. So lots to keep you busy over the next few years. Great. Well, if there's no more, doesn't seem to be any other questions from the audience. So I think we'll leave it there. We'll wrap up there. So thank you very much to Annita and Marco for your very interesting presentations and the really good discussion, I think, there afterwards as well. Thank you to the audience for your questions and for tuning in. Please don't forget that coming up next, there is a networking lounge. So while we are all obviously virtually meeting today, please do try to meet up with other colleagues in the networking lounge where you can mix and mingle and meet together. So the link will be on the platform page that you are on now. You will see a link that you can go straight to the networking lounge. And please do look at the next upcoming events that Euroheat Power will have on for the Congress 2021. Thank you very much.